Welcome to The Explainer. I'm absolutely thrilled you're joining us, because today we are exploring a scenario that honestly sounds like pure science fiction, but it is actually deeply grounded in real orbital mechanics and Earth sciences. Imagine just for a second that our closest celestial neighbor just vanished. No massive explosion, no sci-fi warning sirens, just gone. How exactly would our planet react? How would life adapt to that? Today we're going to walk step by step through a dramatically realistic timeline of exactly what happens to Earth when we suddenly become a solo traveler in the solar system.
Okay, let's dive right into this. At exactly 2:40:08 UTC, the universe corrects a variable that is maintained for 4.5 billion years. Deep within the volcanic shield of Mauna Kea in Hawaii, the seismometers there don't record a tremor. They don't record an earthquake. Instead, they register this uniform planetary sigh. It's basically a single, incredibly low-frequency wave that travels through the Earth's crust, the mantle, and the core, all simultaneously. And in that one instant, our night sky is robbed of its brightest companion.
Part 1. The Barycentric Jerk. To see the immediate physical impact, we have to look at what's happening on the ground. Over in Hawaii at the Gemini North Observatory, Dr. Elena Vance's telescope suddenly throws a massive cascade of critical errors. Why? Well, her pointing software completely failed because the primary gravitational lens, the literal massive weight of the moon itself, just vanished from the sky.
Now, what's really interesting about this slide is how it explains the barycenter. You see, the Earth and the Moon don't actually orbit each other. Not exactly. They orbit their shared center of mass. Because Earth is vastly heavier, this pivot point isn't floating out in space. It's literally buried deep within the Earth's mantle. So every single day, Earth executes this tight, looping dance around that internal pivot. But when the Moon ceases to exist, that shared center of mass instantaneously collapses straight back to Earth's geometric center.
And this is where things get wild. That collapse triggers a massive physical correction. Earth suddenly shifts, literally jerks about 4,700 kilometers outward in its orbital plane to compensate for all that lost mass. For anyone standing on the surface, this event, which scientists call the barycentric jerk, would be felt as a faint, momentary drop in gravity. Just a split-second loss of weight, followed by a low global hum as the planet settles into its brand new, totally independent path around the sun.
Part 2. The slack water. While the solid Earth jerks, our oceans completely lose their rhythm. Let's head over to the Bay of Fundy in Nova Scotia. It's famous for the world's highest tides. There, marine biologists like Dr. Marcus Thorne would literally watch the water stop its predictable breathing. Instead of the slow, majestic turn of the tide, the oceans just begin this chaotic, slurring slosh.
The resonance of the world's oceans is instantly broken here. Without the moon, that massive lunar tidal bulge collapses entirely. All that displaced water migrates away from the equator, desperately seeking a new equilibrium that is now governed solely by the sun. So, our tides don't vanish completely, but they instantly shrink by 60%. And that familiar 24-hour and 50-minute cycle, gone. From this moment forward, high tide happens at exactly noon and exactly midnight, every single day, like clockwork.
Now, for human infrastructure, this sudden drop is a total disaster. Every major port and shipping lane was engineered for those higher lunar tides. But for the biosphere, it's literally a death sentence. Millions of intertidal creatures are instantly stranded in mudflats that are never going to see water again. Vital salt marshes, which are basically the nurseries for ocean fish, just completely dry out. We're looking at the collapse of delicate salinity balances, leaving behind incredibly stagnant, muted seas.
Part 3. The Velvet Blindfold. The tragedy doesn't stop at the shoreline. It brings a profound, crushing darkness to the land. Moving into the dense tropical rainforests of Gabon, the sudden extinguishment of moonlight throws every nocturnal ecosystem into complete disarray.
Just think about the African leopard. Its eyes are perfectly designed to amplify ambient photons so it can hunt at night. With the moon gone in a flash, even this incredible apex predator is left completely blind in a velvet-like darkness. And it cascades from there. Down in the Great Barrier Reef, massive coral spawning events that rely precisely on the full moon completely lose their synchronization. The daily vertical migration of trillions of zooplankton stumbles, which disrupts the whole marine food web. Even migrating songbirds find their internal compasses totally messed up. Life on Earth literally loses its oldest metronome.
Part 4. The Unstabilized Axis. Let's jump 2 weeks forward. The immediate shock has kind of settled, but at an emergency global summit, scientists realize the true existential threat. We have completely lost our gravitational gyroscope.
And that brings us to obliquity,
This is simply the angle of our planet's tilt, which right now sits at a very comfortable 23.5 degrees. This tilt is the only reason we have predictable seasons. For billions of years, the moon's gravitational pull on Earth's equatorial bulge has acted as a brake. It stabilized us. Without it, we're completely at the mercy of the gravitational pulls of massive gas giants like Jupiter and Saturn.
If you look at this timeline, you'll see how this builds into a global catastrophe. Over thousands of years without our lunar anchor, that tilt starts to wobble wildly. It might drop to 10 degrees, which wipes out seasons entirely, or swing violently up to 45 degrees, bringing on extreme, lethal summers and deep frozen winters. Fast forward millions of years and we'd hit a chaotic 85-degree tilt. We're talking about an equator baked under a permanent sun, while the oceans just freeze solid in perpetual twilight. No way we survive that unchecked.
But honestly, we wouldn't even have to wait thousands of years to feel the pain. Check out this table. Within just 5 years, the lack of tidal mixing drastically alters massive ocean currents, like the Gulf Stream. Up in the atmosphere, the jet streams begin to buckle because there are no atmospheric tides to guide them. This rapid destabilization means the world's major agricultural breadbaskets are facing unprecedented droughts and floods. In a matter of years, we're living on a planet radically different from the one our entire civilization was built upon.
Part 5. The Lost Horizon. This brings on an incredible era of lunar grief. Beyond the physical devastation, the psychological toll of staring up into an empty black void is immense. Plus, the economic chaos is just staggering.
Billions of dollars in lunar-specific space hardware are instantly rendered useless. High Earth orbit satellites get thrown completely off by the sudden gravity shift, drifting into useless trajectories and crippling global communications. We're totally cut off. But humanity is incredibly stubborn. Enter the Flywheel Initiative. Dr. Vance and others realize that, okay, we can't replace the 73 quintillion metric tons of the moon. Actually, scratch that, we don't need to replace the mass. We just need to replace its stabilizing torque through massive, unprecedented planetary engineering.
Part 6. The New Ecology. Fast forward 5 years to a period known as the Great Slackening. Earth's biology has been forced into a brutal natural selection process. Take the Georgia fiddler crab. Its ancestors bred perfectly to the lunar clock.
But through incredibly rapid epigenetics, some fiddler crabs adapt their breeding strictly to the new, weaker solar clock. Life finds a way, right? But human civilization has to force its own adaptation. We spend trillions rebuilding coastal harbors for diminished tides. We completely abandon traditional agriculture for massive indoor vertical farming to survive the erratic jet streams. And to fight the crushing darkness, we actually launched the Selene constellation, a vast network of orbital mirrors that reflect a cold, bluish artificial sunlight down onto our cities. We literally build our own machine-generated moonlight.
Part 7. The Millennial Wobble. Jump an incredible 1,000 years into the future. The moon? It's just a myth in our digital archives now. Earth's tilt has drifted to 22.1 degrees.
That subtle shift has totally redrawn the global map. The Antarctic is now temperate and densely populated. Shifts in monsoons have brought green life back to the Sahara Desert. The Earth's wobble is happening, but we haven't let it destroy us. How? The Barycentric Ring. This is a spectacular, active network of millions of interconnected solar sail platforms right around the equator. It uses the gentle pressure of solar radiation to constantly push against Earth's equatorial bulge. We basically became our own gravitational anchor to continuously damp out that deadly planetary wobble.
Looking back at this whole journey, the words of Dr. Elena Vance really hit the nail on the head. She said, every stone, every drop of water, every beat of a wild animal's heart was shaped by that giant silent rock. We have to become our own moon. And that brilliantly captures our new reality. We learned the absolute hard way that our world is an incredibly interconnected system, and without our natural shield, we had to step up to artificially engineer the delicate balance of our own home.
Which brings us to the ultimate takeaway here. We take the quiet, brilliant machinery of our solar system for granted every single day. But if our silent companion vanished tonight, if the skies went permanently dark and the tides went slack, could humanity truly step up and engineer its own survival? It's a terrifying scenario to think about, for sure, but it's also a pretty massive testament to our stubborn resilience. Thank you so much for joining me for this explainer. Keep asking those big questions, and as always, never stop looking up.
Please like and subscribe.